and changing waves. I try to explain that simply compare two theory, we can get maybe some new results, maybe without new proofs or something like this. But it is necessary to understand how the thing is running. And this talk is based on the, it is our story is based on the papers by John and Jos, Toland and Jos, and me. Therefore, there is something 3 or 4 papers, and there is the recent result of Thomas Azart and Pietro Bauti. And therefore, this is something combination of ideas which belong really, in fact, different people, a number of people. Okay. Now I try to explain what is 3D and changing waves. What does it mean? Suppose you have two systems. I'm sorry, I'm not master of drawing in computers, therefore maybe on that cut. Suppose you have two systems of plane waves, one moving in this direction and other in this direction, linear waves. When they, after interaction of these waves, after superposition, this vertical velocity cancel it, and we get some diamond structure with moving in the horizontal direction like traveling waves. Therefore, you can make many exercises in this direction and get many periodic three-dimensional structures which are moving with constant speed in some direction. Therefore, it will be three-dimensional traveling waves. If you have two identical water waves which are moving plane linear waves, simply some sinus, which are moving in this direction after collision and superposition, exactly in opposite directions, absolutely identically. And the result of composition will be changing waves, which is not moving, but simply oscillating in time. Like pendulum, the water come up, then stop at the moment, then fall, and then it is exactly this phenomenon. Really, we have the problem of superposition of system of two waves, two traveling waves. Therefore, it should be the theory, mathematical theory should be the similar. I am focused on the theory of 3D waves simply because it is better developed. And in some sense, you can say more about these waves. Okay. What is the basic assumption? Of course, we assume that the water occupies some curvilinear half space, bounded by free surface. This is free surface. Eta is a known function as usual in theory waves. We assume that flow potential has this V, has this form. C is velocity of the wave propagations, the velocity of wave propagation. And phi, this phi, like direct phi, is the usual velocity potential in the moving fray. And the rest states corresponds when this phi curvilinear phi, var phi is equal to 0. Okay, let capital X denote the horizontal projection of vector x, simply x1, x2, it is plane vector. And x3, therefore x3 will be the vertical coordinate, it is simple. Okay. We choose C like some velocity scale, and let L will be some, it will be defined later, will be space scale in order to write equation in dimensionless form. Then we can introduce the, Then we can introduce some square root, inverse square root of root number like this. And then after scaling, we can rewrite the equation. And next a little bit more notations. We use Zakharov variables. After 50 years experience of choosing different variables, it turns out that Zakharov variables are most optimal, finally. Yes. Therefore, unknowns function eta, and it is a restriction of low potential on the free surface. The Dirichlet-Neyman operator was defined on the previous lections, therefore I have nothing to say about this. Recall only that this is derivative. It is not normal derivative because of this term, where phi is harmonic function solution Dirichlet problem with the data is where data is psi. Okay. Then the governing equation for psi and eta can be written in the following form. What is U? We assume now, after scaling, that velocity c is simply absolute value of c is equal to 1. Then U is now U is c, it is unit vector. We defined and determined the direction of the wave propagation. Roughly speaking, now the c is in Froude number, was absorbed by Froude number, and now instead of the velocity field c, we have velocity field u. It is a system, it's a relatively simple system, but it is quasi-linear. In some sense, one can say that it is strongly nonlinear. System of integral differential equation. We can write this system as operator equation, where F1 corresponds to the first equation and F2 corresponds to the second equation. Don't pay attention too much to this formula, it is simply decoration. Okay, periodic structure, periods, it is important. There is two lattices of periods. One is the lattice in the plane of wave vectors. Wave vectors, it is of course physical quantities, but they do not relate it directly to what we can see really. It is vectors in the space of Fourier variables. And the wave vectors generate some lattice gamma prime. Real lattice of periods, which what we can see, is the dual lattice. It is defined by standard way. For example, in theory of crystals, it is known, very important things. Therefore, the Fourier expansions of function eta unknown and psi, psi, it will be in these terms. Yes. Further, we consider the following things. Let us take a couple of words about this lattice, about this vector case. Look here, I take here 1 and take here 1. This is because of choice of scaling parameter L. I say this the typical length that will be chosen. We can choose a parameter L, such here is 1. Here is 1, but here there is some multiplier lambda. Therefore, diamond phase. In this case, we can see what is it diamond phase. Diamond phase corresponds lambda is equal to 1. T1 is equal to T2. Therefore, it is exactly diamond and diamond configuration, rational. And see, in this case, lambda is equal to 1. It is not important, so important that it is equal to 1. It is important that it is rational number. Yes, now we can go further. Okay, this is how I introduce it Fourier transform. And we can introduce, because little periods are given, and then we can introduce the standard Sobolev norm in terms of Fourier transform. K is a dual variable, it is integer. Dual integer variable of Fourier transform. Okay. Okay. Now, I also introduce very important vector V, which is tangential horizontal projections of the velocity field but velocity of liquid particle on free surface. You see, we consider moving liquid particle moving on free surface, it is vector field v of course, velocity is linear, somewhere in all direction, but each horizontal projection is this. This simply some auxiliary quantity, doesn't play any role, technical reason. Okay. Important formula. Important formula. Our analysis is local analysis, and then we have to study linearized equation. But because this problem is not related to small divisor and some difficulties, we have to study linearization of the nonlinear system, not on the trivial solution as usually, but on some an arbitrary vector field, really an arbitrary vector field. U is just simply couple phi and eta. Couple unknowns defined as one capital U. Okay, there is very nice identity. Here there is some operator L mu U. I discussed it, it is very important for ours. Which x of delta phi delta eta. It is linear, it is cathode derivative of operator A, F, which is main principal part of this cathode derivative, which is some reminder. Reminder vanished when U, mu, and U is explicit solution of our problem. I try to explain U, which is simply phi and of psi and eta, mu is unknown, so we cap fruit number, and U is unknown direction of wave propagation. Yes, it is exactly like this. For Newton method iteration scheme, these terms can be neglected in any case, because the Newton iteration scheme really our considerations are based on the Nash-Moser theory. Nash-Moser theory is some version of the Newton iteration process. Newton iteration process has some what is called super conversions. It just converges so rapidly that it is impossible to imagine. Therefore, all the terms of order discrepancy can be neglected. This fact is the key point. It is the key point of the KAM theory. It's a key point. Therefore, we have to focus it, our study should focus it on the operator A. What is it? Well, it's very simple. Each consists of, this is matrix operator, consists of Dirichlet-Neumann operator. It is simply coefficient. Really, it is normal derivative up to some multiplier. It is normal derivative of the acceleration or gradient pressure on the free surfaces. Roughly speaking, if A is positive, it is good. If A is negative, we have related instability. Yes. For trivial solution, it is something like mu. Yes. And J is very important stuff. J is simply differentiation, the operator gradient or differential along vector field V. Yes, we can reduce this equation, it is very easy, to equation of this form. Now it is very clear. Yes, now it is very clear. What is written here? Ah, yes, correct. It is very clear. You have second order derivative here. You have second order derivative here. And you have first order operator, Dirichlet-Neumann operator here. It is equation, it depends how to consider it. Formally, it is equation of parabolic time because you have the first order term and second order term. But from the point of view of operator equation, it is hyperbolic because one term is positive, another is negative. Here minus g, roughly speaking, this is g squared, it is negative operator. Yes. Okay, therefore we come to problem to find the solution. If you would like to solve linearized problem, you have to find the periodic solution of equation which really is hyperbolic. And what is bad, it has double characteristics. Okay. In the case of when we linearize this equation on the trivial solution, we get this equation. Sorry, I take h is simply 0 in this stuff. And this is some dispersion equation of characteristic determinant. It is clear that it is hyperbolic. We have plus and you have minus. But in this case, coefficient of course constant. U0, which is horizontal unit vector, and mu c, it is some initial value of crude number. Now, the general Nash-Moser scheme consists of three parts. First part, it is to prove that operator f is well defined, infinitely differentiable, it is enough, and has very smooth properties. Next part is to prove that system has at least one approximate solution of any order. This solution may be constructed like trigonometric polynomial. And the third is more complicated. It is to prove that for any this equation with variable coefficient has a solution which admits some estimates. I have to note that smoothness property of solutions may be much less than smoothness properties of right-hand side. It is peculiarity of Nash-Moser scheme. This is enough. KM theory. Because of superconvergence of Newton iteration scheme.
Beta alpha means L beta L alpha.
What?
Beta is H. It's Sobolev space or?
It is normal Sobolev space.
Sobolev space.
Yes, a Sobolev space. But if you sacrifice some beta takes, for example, beta pi less than beta, you can just replace it by C space. It is the loss of smoothness, which may be as big as possible, as large as possible as you doesn't. Okay. First result about C infinity. It was proved, investigated by many authors. I mentioned it is Craig and Nichols, Lenz, you and Nichols, and finally Buffoni. There is a number of authors who investigate this problem. It is well known that it is C infinity operator. Okay, there is some estimate. Okay, now approximate solution. Approximate solution was constructed by Craig and Nichols, and also yours and me. And maybe it is not the best result, but maybe I explain what you mean. We have the period latches characterize three numbers. Tau 1, tau 2, it is component of period vectors, and lambda, it is some ratio between period vectors which forms the latches of periods. Therefore, we assume that they are given. Yes, assume that it is a very important condition, that this dispersion equation for trivial solution, therefore it is condition on mu c, has only solutions. Really, if we neglect k is equal 0 like trivial, it have only one symmetric solution, for example, such that potential is odd and the free surface is even, it is strong condition. There is no resonance. Yes. Under this assumption, the system there is two psi, because you have some supercomposition of two waves, therefore psi 1 it is magnitude of one way, psi 2 is magnitude of the other way. Thus we get that for any capital N there is approximate solution. Really it's trigonometric polynomial, but complex fraction. Okay. Yes, this okay. Let us discuss a little bit characteristics of our equation. This equation with double characteristics are vectorial line of the vector field D. This means that they are solution, it is characteristics of our equation of this dynamical system. Really, V is not an arbitrary vector. All our equations originated from some water wave theory. There is some energy principle, some Hamiltonian structure. Really, V is geodesic lines on this surface, geodesic in Jacobian matrix. This point is very important. I would like to say, let me try to explain. Let's, for simplicity, I have periodic lectures. You have some landscape. It will be landscape of atom. You have some geodesic line which come through this. Geodesic line is characteristics. If you take unperturbed trivial solution with constant speed, you have something, this line will be something like this. It is straight line. If I have solution very small perturbation, it does not follow from general theory that this equation has solution like this. It may be deviate and maybe have very complex behavior. You see? There is some notion, it is geodesic flow, I say, on this surface in Jacobian matrix. Let us take these lines, assume that this is something like x2, this vector lambda 1 plus or lambda 2, this direction. Lambda 2 is vectors of period. Lambda 1, lambda 2. Therefore, in order to get good problem, we have to require, it is hypothesis, it is conditions, that trajectories of this system are not deviate on the big distance from some this line. Roughly speaking, distance between every solution of this equation, characteristic, and this line, it should be finite. Moser called this number rho is rotation number. For diamond waves, we can assume without loss of generality that this is, okay, this rotation number is 0, because it is rational for diamond phase. For general symmetric case, it is maybe non-rational, non-zero. The theory, there is a Moser theory which says that we discuss the existence of, really we have to construct foliation we have to construct foliation. We require that every trajectory of this line, of these equations, every characteristic of our linear equations, deviate from this straight line are not more than finite distance. This following measure, we can say that it is geodesic foliation with rotation number rho. Existence of such foliation is not obvious. Moreover, if the surface magnitude is sufficiently large, there is so-called phenomenon Aubrey set, which gives that such foliation exists only on some counter. We have only some counter set of these trajectories between them. Therefore, it is a very interesting question. The behavior of motion of liquid particles on the free surface may be very complicated, very chaotic, and it is topological invariant rotational number, and existence of this. It is extra condition. It is extra condition. Yes. Now we have. Now we can turn to this equation. Okay. We can assume now what is the lambda? This was the ratio of lattice vector lambda 1, lambda 2, which forms the periodic lattice. Lambda is rotational number of the sum and perturbed flow. Okay. Now I can solve this. Yes, for approximate solution, this rotational number and this is the analytic function of psi. Really, it is polynomial. Okay. Next, there is some property about some properties of the operator normal Dirichlet-Neumann operator. We need something that the operator may be decomposed in this manner, in this like in three parts, where first order operator G is 0 operator J minus 1. I have to note last year this was developed. It was not developed. It was developed early, but it was used for this problem in integration. Very powerful mathematical tool, paradifferential calculus and paralinearization. I don't. It is very interesting things. There is a lot of things developed by French mathematicians, but unfortunately we have no time for this stuff. I only say that using paradifferential calculus, we can give the explicit formula for G eta. Well, unfortunately, there is no time to explain. This is so-called some paradifferential multiplier, which is very good operator. But it is a very explicit formula for very complicated operator. And reminder is sufficiently small. Therefore, using this on something like this, I can start our procedure and now close to finish. First, what we have to do, it is to replace, our equation has some derivative, second order derivative along characteristics, and normal operator, Dirichlet normal operator has also contains the derivative first order. Therefore, you have some derivative along characteristic and some derivative is in the direction orthogonal characteristics. First step is to make change of independent variables such that coefficients at principal part should be constant. Coefficient at principal part, it is coefficient at the second derivative with respect to long characteristics and the first derivative in the normal direction to characteristics. Okay. This is really, this question is close to problem of existence of geodesic foliation like Moser. It is the same problem. Now, we are looking at the change of variables x of y. X is function of y should, after some calculation, we obtain that x should satisfy this differential equation. Here, f is calculated if v in terms of v, which is correct. Also, there is some a this here, and nu is constant. Here, rho and nu really unknown constant. This problem is known as mathematics in KM theory. It is a problem of the integration of vectorial field on the theory. It is first problem of KM theory. With one peculiarity. Here we have extra term. There is no such term in KM theory. It is, but miraculously, this is so-called, without this term, it is so-called conjugate problem. It has very, very specific algebraic property. We can solve this problem using Newton's scheme. It is, let's see. It turns out that if you can take the determinant of x prime, it is Jacobian of x. It is also a conjugate problem. Therefore, this equation cannot be solved. After solving this equation, we can reduce our problem to equation in the form where G, it is operator with constant coefficient now, very good. P is some periodic function, J1 is first order operator, and watch each symbol. It is first order operator, but here in main part you have coefficient 1. Here is derivative of, if I assume that G square is the leading derivative, it is the low order term, it is the low order term. Moreover, we can replace our equation in this form. It is pure technical algebraic exercises. Then if I introduce this linear operator, it is minus Laplacian, it is constant coefficient operator. Then our equation can be rewritten our operator can be rewritten in the form. Therefore, it is leading terms, it is low order terms, it is zero operator, it is minus 1. Okay. Thus we come to this equation. This equation it can be solved, but discant method was proposed in paper by Toland and me many years ago. Idea of this method is to replace the complicated Fröhlich-Spencer operation with infinite matrix. It is very primitive. I can explain it in a couple of words in order to be clear. It is very simple thing. Suppose you have equation. Okay, if I multiply, I would like to kill this term. Everybody knows from the university course of the differential equations that it is possible simply multiplying, if I multiply this equation by something gamma, really I take what is commutator with some multiplication, and finally I get something yes. This term is obtained because I multiply by gamma and make a commutator with the first. If I solve this equation, it is ODE. I kill this term. Of course, in our case, it is not ODE. Here, A is some pseudo-differential operator, but I can take gamma pseudo-differential operator and write this equation for the symbol of gamma. Result will be the same. Then I can continue. Therefore, it is pure algebraic procedure. Really, no estimates, no. Okay. What we finally get? Finally, we get equation in the following form. Here we have some. It is also interesting equation. Here are some quantities. these quantities can be calculated. It is big integrals of solutions of the problem. Therefore, the wave can be characterized by some mu2 mu0 most important, is psi square, is proportion of psi square. Some characterizes some spectrum of some, I don't know what is the meaning of these quantities, but seems there is sequence of number which characterizes wave. The meaning of this number is clear. Where is low order operator, and I can solve this problem. Okay, now there is no estimation that now, but at this, starting from this point, I have to impose some conditions for coefficients, for rho, for rotational number. Each is different in conditions. If these are fulfilled, therefore this condition are fulfilled for almost all rho and for almost all coefficients, therefore it is general case. Mu0 is psi square, therefore and this okay. Then we can solve linear problem and finally get very complicated results. There is the set of psi1 and psi2 of full measure such that such that 0 is Lebesgue's point of this measure, such that from all psi from this set of full measure, our problem has explicit solution in Sobolev space H with big S. And this is the end of story. Okay. What is the relation about standing waves? The difference between standing waves, formally from the mathematical point of view, is only that I have replaced V by gradient this operator, J. I have to replace it with respect to d. And this is the only difference. Now, instead of characteristic lines, I have to use the temporal variables. Everything is running as before, therefore, for stand, with one exception, with one which at this point I have to be honest. In theory of standing waves, the normal derivative operator acts only in space. It is not pseudo-differential operator. When we wrote our paper, especially with John, we don't know that this kind of operator are named Redon transform. But now I discovered there is huge theory of this operator. But everything is not needed after that last year. Alazar and Baudin noted that all this operator, it can be considered like so-called Fourier operator. Fourier operator introduced by Hermander is a generalization of the pseudo-differential operator. And this is very powerful mathematical technique. Really simplify a lot. And really discount method are not used because we can make using the Fourier integral operator, we can make direct analysis. Okay, therefore Diamond's waves exactly correspond to standing water waves. At this point I would like to finish it, but general waves with irrational rho. What is the analogy? It should be the analogy. There should be non-stationary analogy of these big points. This relates, this we can come back to the discussion between Relay and Stokes. There is some exchange of latches, John, correct? Because you sent me this latch. I learned this from you. Yes, the relay do not believe on existence of standing waves.
What's the name? Lorray?
Relay. Don't believe. By a very simple reason. Standing waves should be two identical waves with identical speed, which is very unlikely on practice that there is two identical waves, absolutely identical waves with absolutely identical speed only opposite direction. And there is, should be something combined way because there is some small discrepancy. But it is not standing wave. It will be something like some combination of traveling standing wave or something like this. And if rho is a rational number, and I consider the non-stationary problem, periodic solution, I exactly get the wave of these types, combining, traveling, standing waves. And that's, thank you, that's at this point. There is a number of solved problems in this area, but I suspect that everybody tired.
Okay. Any questions?
Yes.
Well, I was going to, because of your last discussion, I was going to offer to that question mark, why isn't the analog being a standing wave with two quasi-periods? Maybe not standing wave, but a periodic, time quasi-periodic solution, which is spatially
Yes,
periodic.
yes.
Two periods.
One of the unsolved problem is quasi-periodic solution. But it is here. It is not like I am talking about. I was talking quasi-periodic solution. It seems that we are looking potential like quasi-periodic function. You see, in our case, potential is periodic, but in quasi-periodic case, the velocity potential should be quasi-periodic function.
In time, not in space.
In time, yes. But you know the theory of elliptic equation in space of quasi-periodic function may be more difficult than theory of hyperbolic equation as this one. Unfortunately, Laplacian equations in the space of a quasi-periodic function, which is absolutely unsolved problem, and Mozart discussed this, except one case, which was developed by Kozlov, not other Kozlov, but it is very special case with very special nonlinearity, and Mozart exploits this result. Therefore, the question of quasi-periodic solution in both cases is a very important case. It is absolutely unsolved problem. Maybe it needs other technique, maybe some very expensive method or something. Definitely this simple trick with this kind of method does not work.
How's the solution unique? Probably not.
Everything leads to some question. I mentioned the solution exists not for every psi, but from some psi from some really counter set. You see? Yeah. This counter set is unknown. It is integral part of the problem. You see? Really, these psi are irrational numbers satisfying some special Diophantine conditions. It is exactly, I wrote some mucata, it is exactly this mucay. But if it becomes rational, you have secondary bifurcation at every point. It seems it's at every point. Very simple explanation is parametric resonance. Really, we do equation with periodic coefficients, therefore it's parametric resonance. You know that parametric resonance forms some kind of complicated lines where solutions separate stable and unstable. But in the case of infinite dimensional, these lines becomes dense set on the plane. Therefore, it is a question about parametric resonance for infinite dimensional case. Nobody knows.
Okay, on that mystery, perhaps we should end the day. Thank you very much.